So in this problem, we need to determine the equation of a parabola such that the focus is at the point 0, 5 and vertex is at 2, -3. Let us begin. Now, before beginning, let's try to understand the problem graphically. What we'll do, we'll consider a straight line. And on this straight line, we're going to consider 2 points. Now, let's say one of the point, this particular point is the vertex P with the coordinates 2, -3. And the other point, that's denoted by F with the coordinates 0, 5. Now, by definition, any line on which the vertex and the focus of a parabola lie is referred to as the axis of the parabola. So that means this particular straight line is going to represent the axis of a given parabola. Now, what we'll do, we're going to choose another point on the same line, and we're going to call it point A. Let's say this has the coordinates A, B. Now, point A's position is important here. It's chosen in such a way such that its distance from the vertex is exactly equals to the distance of the focus from the same vertex V. Now, what we'll do, we're going to pass a line through this point A in such a way that it is perpendicular to the axis of symmetry line. Now, we know any line which is perpendicular to the axis of symmetry line and also is at a fixed distance from the vertex, then this particular line will be referred to as the directrix of the parabola. So, in order to find out the equation of the parabola, our goal will be to determine the equation of the directrix, and we need the focus. We already have the coordinates of the focus. So, let's try to find out the equation of the directrix. We'll go step by step. First, let's try to find out the slope of the line formed by slope of the axis of symmetry. So we're going to denote the slope by the letter M1. All we have to do is take the ratio. In the numerator, we'll have to take the difference of the y coordinate. So let's do the focus minus the vertex. So we'll start with the y coordinate of the focus, which is 5. And from here, we're going to subtract the y coordinate of the vertex. That's -3. And in the denominator, we'll have to consider the difference of the x coordinates. So we'll start with the x coordinate of the focus, and from here we're going to subtract the x coordinate of the vertex. Now that means we have 5 minus -3, so that's going to be +8 divided by -2, giving us -4. So the slope of the axis of symmetry line is going to be -4. Now, if we know the slope of the axis of symmetry line, we can also find out the slope of the directrix lines, because from the properties of straight line, we know that the product of the slopes of these two perpendicular lines is going to be -1. So we're going to consider the slope of the directrix line to be M2, such that we have M1 multiplied to M2, that will be equals to -1. So that's a definition of straight lines. Now, we want to find out the slope of the directrix line, which is M2. That will be simply the negative reciprocal of M1, and we have already obtained the value of M1, which is -4. So that means our slope value comes out to be +1/4. This is going to be the slope of the directrix lines. So let's keep it aside for the time being. Now, in order to find out the equation of the directrix line, we will be using the point slope form. The point slope form simply states that if we have a straight line passing through a point having the coordinates x1, y1, and the slope of that particular line is also known, which is m, then the equation of the line will be given by y minus y1 equals to the slope times x minus x1. Now, we have already obtained the slope of the directrix line. We need to find out the point A, because through the point A, the directrix line is passing. Now, how shall we find out the coordinates of point A? That's a very simple task. Here, clearly, from this diagram, the vertex is the midpoint of the line segment joining point A and point A. So here, you can use the midpoint formula to find out the coordinates of point A. In other words, we can say that we can take the sum of the x coordinates of A and the focus, so that's A plus 0 divided by 2, and for the y coordinate we take the sum, so we have B added to 5 divided by 2, and this coordinate value is going to be exactly equals to the coordinate of the vertex, so that's 2, -3. So since they are equal, this means that we can equate them. So we have A plus 0, that's simply A over 2, so A over 2 will be equals to 2, giving us the value of A as +4, and then we have B plus 5 over 2 equals to -6, which means that the value b will be equals to negative 11. So that's going to be the coordinates of point A. So we've successfully obtained the coordinates of point A. So let's write it down here. So we have A given by 4 comma negative 11. So now we can easily find out the equation of the directrix line, because we have the slope of the directrix and we also have the point through which the directrix line passes. So the equation of the directrix will be, let's use the point slope form. We have y minus y1. So y1 will correspond to the y coordinate of point A. So that's negative 11 equals to the slope, which is 1 over 4. We have already obtained in number 1. And this will be multiplied to x minus x1. So that's 4. So let us simplify the equation. So here we have y plus 11. We're going to multiply throughout by 4, so equals to x minus 4. We have 4y plus 44 equals to x minus 4. So rewriting the terms, we get x minus 4y minus 48 equals to 0. So this is going to be the equation of the directrix line. So now we have successfully obtained the equation of the directrix line. We have the coordinates of the focus. Now we are ready to obtain the equation of the parabola. So here we have the vertical line is going to represent the directrix line. So we have x minus 4y minus 48 equals to 0. And the coordinates of the focus, that's already given to us. That's 0 comma 5. Now, here I'd like to point out that by no means get confused that this is the coordinate axis, because here the x coordinate is 0, which actually tells us that the focus is lying on the y-axis or not the x-axis, although the diagram might suggest that the focus is lying on the x-axis. So be careful there. Now, what we'll do, we'll consider a point, let's say a point P. Point P has the coordinates h comma k. Now here P is going to represent the locus of the parabola. Now the point P is chosen in such a way such that if we join point P and point F and we drop a perpendicular from the same point P on the directrix line, let's say it meets the directrix lines at M, then by definition of a parabola, the length PF must be equals to the length PM. So PM is the perpendicular distance here. Now we can easily find out the length PF by using the distance formula, because we know the coordinates of the endpoint. All we have to do is take the square root. Underneath the square root, we have to take the difference of the x coordinate. So we'll do h minus 0, square this value, and then add it to the difference of the y coordinate. So that's k minus 5 whole square. This will be equals to PM. Now what's PM? PM is the perpendicular distance of the point P from the directrix line. Now there's a standard formula for obtaining the perpendicular distance of any point from a straight line. Let's go through the formula that we will be using here. If we have a point P with the coordinates x1 comma y1 and it is at a perpendicular distance PM from a straight line, whose equation is given by ax plus by plus c equals to 0, then the perpendicular distance PM will be given by this following expression. So here we are going to use the formula. All we have to do is take the absolute value. Inside the absolute value, we have to consider a ratio. We'll have to start with the coefficient of x of the directrix line. So that's 1. 1 will get multiplied with the x coordinate of point P. We have 1 multiplied to h added to. Now we'll take the coefficient of y, which is negative 4. So we have negative 4 multiplied to the y coordinate of point P, that's k in our case, and then add it to the constant term. So we have negative 48 here. Then in the denominator, we'll have to take the square root. We'll have to take the sum of the squares of the coefficient of x and y. That means take the coefficient of x, square it, and then add it to the coefficient of y, which is negative 4, and then square this value. Now let's further simplify. We're going to get the square root of h squared plus, now what we can do, we can expand k minus 5 whole squared to get k squared minus 10k plus 25. This will be equals to the absolute value of h minus 4k minus 48 divided by square root of 17. Now to further simplify, we're going to square both sides to get h squared plus k squared minus 10k plus 25 equals to, where on the right hand side we have h minus 4k minus 48 whole squared divided by 17. Now, what we'll do, we're going to cross multiply with 17 and rewrite the terms that I'm leaving as an exercise for you. I'm going to rewrite the simplified expression. We're going to get 16h squared plus k squared plus 8 multiplied to h times k plus 96h minus 554y minus 1879 equals to 0. Fine. Now, finally, what we'll do, we're going to replace the value of h with x and the value of k with y. Now, that's going to give us the final equation. We'll get 16x squared plus y squared plus 8 times xy plus 96x minus 554y, that's us actually k here, minus 1879 equals to 0. So this is going to be the required equation of the parabola.